So I'd like to introduce today's speaker. Our speaker today is Jonathan Case. He's the Extension Forester with the University of Maryland Extension. And with that, Jonathan, I'm going to turn it over to you.
All right. Thanks a lot, Bob. Yeah, so I've been working with wood energy programs in Maryland since 2010 with a number of capacities. And the goal here today, I think, is to provide a little bit of background on wood burning, especially with regards to how that affects the certification of stoves and use of stoves, some current things that are going on now, or the different types of technology that's out there in terms of wood and pellet stoves and outdoor wood boilers, and some changes in EPA, new source performance standards that are impacting the industry as we speak, and some comments on that, and then as well as at the end to talk a little bit just about firewood a little bit and some of the opportunities that lie there. And I want to mention that a lot of the work that I've done in the state of Maryland has been with the Maryland Wood Energy Coalition that was organized in 2010 and working on increasing adoption of wood energy, primarily through commercial applications, but as well as residential thermal applications. And that's what this work is really based on. And a partner in this has been John Ackerley with the Alliance for Green Heat. And I'll have his contact information at the end, and have used some of his slides as well in this presentation. But they're Alliance for Green Heat is committed to to residential wood heat, advancing that further. And I'll make some comments on that later. So with that, let me just kind of move along here and say that just one thing I found when we started getting into the whole area of working with policy folks and others about renewable energy is that in our own state that I know initially a lot of people look at renewable energy, they look at solar and wind, hydro, geothermal, but in many cases, believe it or not, many people don't think of wood biomass really as a renewable resource. And there's a perception out there of wood as a dirty fuel by policymakers, citizens, and others, which creates some real barriers for sure. And that's, as an educator, that's been one of the biggest things we focused on, is educating those folks about the realities of the technology that's out there. And in many states, biomass is barely mentioned as renewables, and we've definitely changed that in our state. And biomass is defined as carbon neutral by EPA, and of course, there's a lot of consternation or comments about that. But just want to put this in perspective. Okay. So I have a question for you all, and I think Bob can facilitate this. Do you heat with any of the following? And I think encourage you to, I guess that would be to mark on any of these if you do. I'm not sure if there was a poll actually set up on this or not, but these are kind of the options that many people pick from.
So let me jump in here real quick, Jonathan.
Yes.
So folks, this is 1 through 5 is the same thing as A through E on the polling. So feel free to chime in using the polling process.
Just curious, do you heat with any of the following, either as a primary or a secondary source of heat? To see a little bit of our audience, I will speak personally as a person who's burned firewood for about 40-45 years. A long-time wood user. So let's just kind of see where our audience shakes out. A few people have replied. Of those that have replied, looks at actually wood stoves or fireplaces, and a large number that haven't replied. I don't know if that means that that would probably be none, maybe. So. That's interesting. So just curious to know about that, who our audience is. Okay. So let's move on. This is a slide that comes from the Alliance for Green Heat, but we look at wood pellet stoves, in terms of fossil fuel reduction. Basically very similar to that of a solar array. Displacing equal amounts of carbon from fossil fuels. So I thought this was an interesting analysis that many times it's not thought of. Of course, it's a different type of energy. We're talking about electrical energy versus thermal energy, but still, the wood energy basically has the capacity for displacing a good bit of carbon, as does solar PV. So what is woody biomass? Well, it comes from a number of different sources. Of course, from native forests. In many cases, as a forester, many of your low-quality material is very suitable for woody biomass uses, for chips or for firewood. Sawmill residues typically are useful for pellets, wood pellets, and that's what they're typically used for. Very desirable material, in fact. And interesting, one of the largest sources of firewood, in many cases, is urban wood waste. I look around the state of Maryland, and many of the firewood producers, many of them are basically tree companies that are basically taking takedowns and using that supply a good bit of firewood in the state. Short rotational woody crops, in this case, is just a very minor component of this. So why is there increasing interest in wood? And I'll make that the case that there has been an increasing interest in wood. And I think it's partly because there is a wood culture. There's no doubt that the ambiance and heat of a wood stove is something that's attractive to a lot of people. And there is a certain culture around people that heat with wood. If you've been involved with any folks in sitting around a fire in the middle of the winter, that type of thing. There's also the economics of it in terms of saving money. An interesting statistic is that 60% of people who heat with wood cut their own. So that's part of that cultural thing as well, as people being engaged with what they're doing. And when you look at the heating costs of everything from propane to oil and that type of thing, the cost per million BTU, which is many times the metric that's used, how many dollars it takes fuel to heat up a million BTUs, wood comes out is basically the lowest cost, pretty much the lowest cost option that's out there. Of course, a lot of people have free access to wood or access to free wood. Of course, everybody knows that wood is not free. Even though you may have some woods out there, you still have to take the time to go out and get it. And you have to have a truck and saw and all the other equipment that goes with it. So it's not necessarily free. And there's this whole issue of heat security, which I think has resulted in many cases in some increases in wood stove use around, because many areas, people in rural areas or ex-urban areas, on the grid, many times because of trees and hurricanes and everything else, if your heat goes out, you're really in rough shape. So having a wood stove is something that at this point doesn't require any electricity. Augmenting a heat pump is a very common reason for having some type of wood stove in the house. And of course, just being environmentally responsible as well as for many folks. So what are the types of residential wood stoves? Primarily, of course, we have freestanding wood stoves and inserts, wood stoves using firewood or cordwood as it's called. And these are the ones that are most difficult to control emissions versus pellet stoves, where you have a standardized fuel, low emissions. We don't have many wood and pellet furnaces in this, at least in our part of the country, in the Mid-Atlantic area. That's more in the Northeast, where it's more economically viable. But we do have a lot of outdoor boilers, and we'll talk about that a little bit as well. So, and I think this has been a problem in terms of the high emissions of the older boilers, and in many cases setting a bad image for wood burning in general. When you look at from census data, and this was again developed by the Alliance for Green Heat, homes heated primarily by wood and pellets, you see that these percentages are relatively low. Although you get in some parts of the country like Oregon, 7.1%, you get up in the far northeast of Maine, 13.7%. For most people, primary heating with wood and pellets is not a high percentage of people. But when you look at certain parts of the country, very rural areas, some places really stick out. These are some high per capita wood heat households in various states around the country. And you see that they're quite high. Going up as high as 40% in Oregon for this one county and some other areas. Well, from census data, there has been an increase in residential wood heat use from 2000 to 2010, according to census data. And you can see these increases are kind of indicated here. Of course, in the southeast, where that's not as much the case, but you get up in many of these northern areas, you see increases in the residential wood heat per capita in the varied 20%, 20 to 40%, and even higher than that. And while 2.1% of families nationally use wood or pellets as primary heat and 10% as secondary, I haven't done the analysis, but again, this takes into all your urban areas. And I think when you really extracted a lot of high population urban areas, you would see that wood use, even as a secondary or as a primary, is probably a lot higher than stated by these overall statistics when you include the entire population. So one of the barriers to wood is wood smoke. And there's major problems with wood smoke in many mountain valley areas. It's resulted in some outlawing or actually not allowing certain types of wood stoves or requiring certain types of regulations to limit its use. There's been attempts to try and transition some of these users to pellet stoves, and of course will those wood users that use firewood transition to pellets. And there's been a number of incentive programs that have been tried, and the question is, do they work? Well, sometimes. The point here is that, and I'll make the case later, that there are some real common sense things that can be done to minimize wood, and many of these rely upon newer technology as well as proper seasoning of wood, for sure. So prior to 1988, there really was, EPA was not involved in the certification of stoves. There was no EPA certification. In 1988, they required all stoves that were going to be sold had to have emissions less than 7.5 grams of particulates per hour. And that's kind of the metric that's used. That's a kind of a surrogate for overall emissions and all the gases and everything that come with it. But this was a major change. And so many of these companies basically stopped being in business. And you see a lot of these stoves around still because they don't rust away or anything. But Timberline and Fisher, these were companies that basically went out of business. And stoves at this point were just a big open box with a pipe in it. And the positive results of this EPA coming in is that you had lower emissions because higher efficiencies. And what this meant is you had to use less wood to get the same amount of heat. And that basically was a real savings for the consumer. You could use less wood, and since you're getting higher efficiency, you're not only getting lower emissions, but they're getting people were getting more heat for the amount of wood that they had to put in the stove. So less labor involved and everything else. So just the important thing to remember here is that smoke is basically unburned fuel. If you have smoke, you have particulates, you have unburned fuel, and you increase emissions. So the idea of the EPA certification was to minimize those emissions. So this is an example of a pre-EPA stove versus a certified stove that came after that. And the big difference, again, like I said, if you look at the old stoves, was a big chamber, went directly to a pipe outside of the smokestack. Very little, maybe they were 30% efficient or something. They just didn't maintain a lot of the heat. You contrast that with the newer certified stoves, which basically work on a similar principle. You have some primary combustion going on, but then you have engineering that basically recirculates these gases back into secondary combustion that raises the temperature significantly. And the result of that is that it burns up all those remaining particulates, so it reduces the amount of emissions because those particulates have been superheated and combusted and finally make their way out the smokestack. Okay, so this is the basic idea of most certified stoves. This is secondary combustion. After the certification, some of the companies that want to stay in business, and I know Vermont Casting's had a number of stoves like this, they decided to put catalytic converters in some of these stoves. And these work the same way that your car works. It takes all these these gases and things that create a lot of emissions going through a catalytic combustor and converts it into water and carbon dioxide. And the problem is that these are really not very popular with users because the catalyst converters were expensive to replace, and in many cases people would take them out and rather than replace them, and you ended up with higher emissions. So, but you still see the use of some catalytic converters, and some people are asking them to come back in some of the new hybrid stoves. So what is the effect of wood stove efficiency on fuel costs? Well, significant. And this is just an example for you right here. If you look at three devices, okay, so here's a fireplace, which basically is about 10% efficient. In other words, you get about 10% of the BTUs of heat out of that for the wood that's put into it. And you had a non-EPA wood stove prior to 1988, maybe 40% efficient. Okay, then you have a newer EPA stove, at least after 1988, So if you have a cord of oak wood that you purchase for $150, to basically the way most heat is calculated for a lot of these analyses is, what's the cost per million BTUs of heat to get out of that device? So a fireplace would be about $59 per million BTUs. And if you figure a house might use, 50 to 70 million BTUs in the winter, that's take a lot of firewood to heat it with your fireplace. A little over almost $15 per million for a wood stove, an older wood stove, and 8.5. So the point is, with higher efficiency, you're saving a lot on the fuel that you have to put in it. So whether you're cutting it yourself, there's large efficiency savings, not to mention health savings and environmental reduction because of reduced amount of particulates in the environment. Well, the real point here is that, okay, so EPA started certifying stoves in 1988. The problem is that those stoves don't go away. And what this graph shows here is if you look at older wood stoves pre-1988, and this bar shows that about 50% of the stoves that are out there and basically in use now are these old, outdated, polluting stoves. And you can see with this little green thing here, this green square, that the grams of particulates per hour is somewhere around 25, which is literally more than 3 times what the level for the EPA certified stoves starting in 1988. And only about 31% of those stoves are the newer stoves. And of course we have pellet stoves and some other boilers. But the problem here is that a lot of the stoves are out there. So how do you get these stoves, out of the, out of there, and replace them with newer ones? That's a big challenge. And the real problem there is, like I said, is that these stoves are made of steel. They just don't go away. So people stop using them. They buy new ones. In many cases, that older stove ends up somewhere else, which is not ideal. So let's look a little bit at pellet stoves. They've come a long way. Some people here may have pellet stoves they purchased, say, back in the early 90s when they first started coming out. And you had a gel you had to put on there and light it and that kind of thing. And it was kind of messy, and they've come a long way from that. The stoves that are on the market now, especially the higher-end pellet stoves, they light themselves, they put themselves out, they have thermostats. All of these easily are under 2.5 grams per hour, which is, I'll bring up in a minute, is the new EPA standard. And the best thing about pellet stoves is they can be pretty much put anywhere, because unlike a wood stove where you need a chimney to be able to handle temperatures over 1,000 degrees or more, all you need really for a pellet stove, as you can see right here, it's a little 4-inch or so vent pipe, and that can go out through the exterior wall. So it allows a lot of flexibility in where pellet stoves can be installed. They do require electricity, so if you're buying it for energy security, you have to have a backup battery of some sort. So that's something to think. And one of the biggest challenges, I think, for the pellet industry at this point is developing better backup systems that will sustain them. And of course, we're using pretty much 40-pound bags of pellets for the most part. Usually buy them by the ton. So how does pellet stove work? Well, very simple. You have these pellets. You put them in a hopper. Typically, they'll hold 1 or 2 40-pound bags. You have an auger here, which twists around, meters out the pellets, brings them into a combustion chamber for the controlled combustion. You have a grate here where the ash falls through, and then you have a fan which kind of blows the heat back into the room. So the biggest problem with many pellet stoves is clogging on this grate. And it's very important to use ash or pellets that have less than 0.5% ash. And also the engineering of the stove. The better engineered stoves just have, they don't clog. And that's probably one of the differences between something you want to be concerned about if you're looking for a pellet stove and you're reading reviews. Because if it gets clogged, you have to turn the stove off and clean it out, and that's kind of a mess. The good thing about this is you only dump the ash. It's very little ash, because pellets are basically very densified wood material, and there's very little ash to mess around with, unlike with wood heat. So wood pellets, there's a big difference in quality. The industry has been called upon, I think, by actually EPA or others to standardize their pellets. And so for the most part, you'll find pellet, premium pellets, super premium pellets. I think the most important thing for residential consumers is to know that you need to have pellets that have at least, most stoves require pellets that have less than 0.5% ash. And most pellets are sold in 40-pound bags on a pallet. One pallet's about a ton, and an average person probably uses 2 to 3 tons a year. And one of the bags are a problem. In many areas, there is bulk delivery, using like a grain truck of some sort. There is some places in Pennsylvania here, but it's not very widespread outside of the Northeast. And you have to have a certain number of people out there using it. And for most cases, many of these people that are using bulk pellets basically have an inside pellet boiler like you see here, and they have a hopper in the basement which is loaded with wood pellets, just like you'd get oil delivered. And this is probably some big change in the pellet industry at some point that will help advance it further in areas where you can get away from bags for the most part. But whether that's going to occur for most folks in the residential markets is hard to say, but it is more common up in the Northeast and other areas where you have colder winters and you can justify indoor wood boilers. So the big change that's occurred right now is that, like I said, in 1988, all wood stoves had to have less than 7.5 grams per hour of particulate emissions. Come the new source performance standards with EPA, starting in 2015, all wood stoves had to have less than 4.5 grams per hour of particulate emissions. Lower number of particulates, the lower emissions, the cleaner the air coming out, and the less air quality issues. Many wood stoves at this point actually meet that criteria. The real challenge is that as part of these standards, starting in 2020, the emissions limit is going to be 2 grams per hour. And that's going to be whether you measure it using a test that uses cribwood or 2.5 grams per hour with cordwood. And most people don't know that a lot of tests that are done for emissions with EPA are done using basically cribwood. It's kind of like 2x4s. And there's a big move to use cordwood, which is more representative of the kind of wood that's out there. So the point is that pellet stoves really don't have a problem meeting this limit. It's wood stoves, and it's an extreme challenge because of all the uncertainties. The other thing that it requires by the new standards is that all stoves their efficiencies have to be verified. In many places you went out to buy a wood stove, you'd find the number of BTUs it performed or the efficiency. And these claims are really not backed up by reliable test data. So at this point, after 215, they have to be, so that on the right is just some average verified efficiencies of wood stoves. Of 111 stoves, about 72%. Hybrid stoves are stoves that have some catalytics to them. Catalytic stoves are strictly catalytic. You can see that most wood stoves are wood. Pellet stoves are around 73%. And then when you look at the emissions for wood stoves, pellet stoves have no problem reaching that 2% or 2 grams per hour, but wood stoves on average have difficulty doing that. So the point here is that, again, more efficient stoves, just like in 1988, they're going to use less fuel, and of course they're going to have lower emissions, which is what we're striving for better air quality. So how will technology change to meet these new 2020 emission standards? Some manufacturers are going back to catalytic stoves to meet that 2 grams per hour. And those would be folks that are basically with wood stoves, not pellet stoves. These are not real popular. It's not desirable because I think you'd run into the same problems we ran in way back when are people going to actually replace these things, or are they just going to remove them? Hybrid stoves are kind of a combination of catalytic and non-catalytic components. And there's this up-and-coming category we call smart stoves, which we'll mention a little bit. And this is where you basically trying to take the user out of the equation with regards to wood stoves, kind of like they've done with pellet stoves. You put the pellets in, and basically, it goes on. It does its thing. Everything's automated. Well, with wood stoves, how you start the fire, whether you have the flue open far enough, how seasoned is the wood, all that kind of thing. Smart stoves basically using computer technology and sensors and things like that to address that. And I'll mention more about that later. So there's a lot of positive changes I think that will come out of the EPA regulations. First and foremost is disclosure of deficiencies based on real data. And because there's going to be, this is real data, you can't just make the numbers up. I think companies, of course, are going to be striving for higher efficiencies to compete with each other. And I think it's just going to help the consumers in the long run save more money because you're getting more BTUs for the same amount of inputs, whether it's pellets or it's wood. Again, the disclosure of real BTU output, again, that's always been a cause of concern in terms of advertising. And all stoves have to be certified even to be sold. In terms of outdoor wood boilers, they are a real culprit in terms of, especially older ones, with regards to emissions. And I'll mention this in a minute, but it's going to reduce the emission limits, especially starting in 2020 for outdoor boilers, and it's going to make it very difficult. It's going to eliminate a lot of the worst actors in terms of high emissions in the markets. And like all things, hopefully spur innovation as well amongst different competitors. So what about wood boilers? Wood boilers, this is why, again, when we talk about burning with wood, many wood boilers, the older ones, have very high emissions. So outdoor wood boilers, this is like 161 grams of particulates per hour. And you contrast that with the newer EPA outdoor wood boilers, which are now have to be sold. You can't sell these other ones really, in most places anyway. You're down to about 18. So you can see this is a magnitude of difference. This is basically a whole decimal point for the most part. So you can see how the newer EPA outdoor wood boilers are much more efficient and have much more lower emissions. So that's a real positive thing. So let's just talk about that for a minute. Outdoor wood boilers are kind of known, regulatory sense, as outdoor hydronic heaters. And so starting in 2015, the newer EPA, they used to be called Phase 2 outdoor wood boilers, are the only ones that can be sold in most places. That's been changed to called Step 1. And this is a picture down here of one of the newer Step 1 boilers. And the difference between this and the older outdoor wood boilers is the old outdoor wood boilers were kind of like the old pre-EPA stoves. You had a big combustion chamber. You could burn anything in there. You could burn, throw whole logs in and, cow parts or bones, whatever you want to throw in there. These newer ones are not. They basically will only work if you have seasoned wood. So otherwise they just don't work correctly. So this is a major change, and of course it's resulted in much lower emissions. What happens in 2020 is that outdoor wood boilers are going to have to meet much even stricter emission standards. I'm not providing the numbers here because don't have to mess with that right now, but the point is that it's going to be very hard for the industry, the outdoor wood boiler industry, to meet those standards. Very difficult with the technology that's available. So in fact, there are some efforts by the industry to bring issue with the EPA to help change some of those emission standards or delay their implementation. So the problem here is kind of like the problem with old wood stoves. A lot of the wood boilers that are out there are basically the older wood boilers. They cause a lot of high emissions, and they really give burning with wood a bad name. And it's very challenging, even with the incentive program, because these are very expensive things. They cost $10,000 to $15,000, and to replace them is no small bargain for sure. But most of the new regulations do require they can only burn clean fuels. So But then again, there's changes in the industry that will occur in 2020, and the idea is to change the polluting image of the outdoor wood boiler. So this is one of the older boilers, and this is a EPA Step 1 or Phase 2 boiler. It's running, and you can see, when it's run properly, very few emissions, much less emissions coming out of this, which is what we're working for. And of course, the Phase Step 2 boilers will even have less. We did some research in outdoor wood boilers and tried to come up with some best management practices. And basically, they're listed right here, and they're on the fact sheet on our website. But the size, when you're sizing a wood boiler, and they come in different sizes, is you don't want to size it for the coldest day of the year, because that means it works at much lower efficiencies most of the year. So you want to make it a lower amount for the more moderate temperatures, and realize in the coldest days of the year you may have to use some additional heat source. But this is where you're going to get higher efficiencies out of a wood stove boiler. And you want to minimize distance from the stove to the home, because that pipe goes underground. Usually it's heavily insulated, but even so it loses heat to the ground. And some of the work that we did, depending on the level of insulation, that could be 10 to 20% of the BTUs could be lost underground and not transport back and forth. So of course, the longer the distance from the house to the stove, the more potential loss of BTUs. You have to bury and insulate the water transfer lines. There's some very good insulating materials out there these days. And using only clean, dry, moisture fuel wood, for sure. On these new Phase 2 Step 1 boilers, basically unseasoned wood basically will typically not work in these boilers. In many cases, in fact, I know the Central Boiler is one company. I think they have actually an auxiliary propane system, so in case it does go out, you can relight it. So obviously that's a problem. So let's move on a little bit, just talking about how these regulations of EPA have changed things up till now. And again, these are some information I got from the Alliance for Green Heat. But of 514 wood stoves on the market, 17% are now certified to meet the 2020 emission standards. I think others are developing as we go along. So there's a little ways to go for some of the wood stoves. And interesting, some of the larger manufacturers with the most stove models are having a tougher time meeting those limits, primarily because they have a lot of different stoves and a lot of different engineering that has to be done. And the interesting thing here about the outdoor wood boiler industry is there's some serious lobbying going on right now to delay implementation, perhaps from 1 to 3 years, so they can have more time to develop the engineering to meet the lower emission standards. So we'll see what happens with that. So, question, and again, this would be A through A, B, C, D, E, F, G. If there's enough of those then on the thing. What would motivate you to buy a clean burning wood stove? I'm just curious. What would be the main thing that would motivate you to buy a clean burning wood stove? I'll just give you a minute if you would. I'll ask Bob if he could put up the appropriate thing. There you go. Okay.
So while people are doing that, real quick, Jonathan, there was a question on the poll is up under your, oh, sorry, wrong thing. They were asking about the emissions you're referring to, parts per million 10, parts per million 2.5, NOx, or other pollutants.
I think it's 2.5, I believe. I believe that's what it is. Okay. So again, we got a few people to answer. Seems like a monetary incentive is always, money is always good. So that's a good thing. Very few, a cold family member doesn't carry a lot of weight, doesn't look like to me. So let's move on a little bit to talk about strategies been used in a lot of states with change-out programs to try and provide some money for folks that say, well, as an incentive to put towards buying a clean burning wood stove. And in 2016, there were 35 such programs. The average incentive about $900 to replace a wood stove, $1,300 for a pellet stove. In Maryland, there is a wood grant program. It's been around since 2012. And again, actually thanks to the efforts of the Alliance for Green Heat and working with the Maryland Wood Energy Coalition. But over 5,000 stoves, and again, the majority of those are actually pellet stoves. And the incentive there is $500 towards the pellet stove, or $700 for a pellet stove, $500 for a wood stove. So again, just these are one way to encourage homeowners and users to to buy a new up-to-date stove and get rid of that, especially if it's a pre-1988 stove. And interestingly, a lot of stoves, we always encourage people typically to go to wood stove retailers. They will provide service and things like that. But interestingly, about half of the stoves in the U.S. are bought in a lot of big box stores. And the Englander stove is mentioned here. So there are some stoves that are relatively low cost. And not to get into this, but many of your I'd say more brands with more options and things and more bells and whistles, you're looking probably around $2,500 to $3,000 for a decent, good quality wood stove or pellet stove. But the price is all over the place, and again, as it says here, not necessarily related to some of these less expensive stoves are relatively have low emissions. Let's talk a little bit about automated smart stoves. The Alliance for Green Heat had a wood stove decathlon back in 2013 to test a bunch of different entries in terms of competing for lower emissions and things like this. And that was on the National Mall in 2013, and now it will be again this November of 2018. And I'll mention that when I get done here. But one of those contestants, it was actually a group from the University of Maryland, engineering students, developed an automated smart stove. Basically, you put the wood in, it takes care of all the burning. You have a phone app, very high efficiencies, very low emissions. I mean, these stoves are relatively expensive compared to some of the others, but this is kind of the start of this whole automated smart stove movement to try and take the user out of it, of the process. And so we can reduce emissions with wood stoves. There is a lot of, I'm going to move past this for a minute because I'm in the interest of time, but no, actually, that was the one I wanted. Public opinion, anti-wood burning regulations. There is a lot of public opinion in certain areas that don't like wood burning, especially those areas where you have mountains, valleys, and some of these valley locations. But it's fair to say that the wood pellet movement is really helping a lot of public opinion. A lot of people like the idea of wood pellet stoves because they're automated. You can easily buy standardized fuel, and they have low emissions. And there are some anti-wood burning groups around, but it's the outdoor wood boilers. They actually, I think, galvanize a lot of wood burning interests. So again, the more we can reduce some of the worst polluters in the wood market, the better off we're going to be, for sure. And that's occurring. There's no question about that with the EPA regulation and other things. There are some options to reduce wood smoke, reducing the number of wood stoves, obviously, reducing the number of uncertified stoves, moving from wood to pellets, and perhaps even most important is ensuring that the wood is seasoned or use compressed bricks, which are also available out there on the market now. So I want to take a minute just to talk about firewood and this whole issue of seasoning, because this is really the crux of the problem with wood stoves. I think it's a lot of the seasoning of wood. And 60% of wood users cut their own wood. And the idea is it takes at least 6 to 12 months to season wood 20% moisture. And the question is, how do you know what 20% moisture is? Well, you see this little thing on this wood moisture meter on the right. These cost about $20 to $30, and I recommend anybody burning wood, processing their own wood, to use one of these and split the wood that you want to use and see what the internal moisture is. Because the problem is that homeowners don't buy early enough, they don't run their stoves well or use seasoned wood, and many of the retailers that sell firewood really don't know what seasoned wood means, and there's no real certification for it. So it kind of creates this real problem with what is seasoned wood, how do you get a reliable source of it, and I would suggest that having your own moisture meter to test it takes out some of the guesswork. So again, hardwood requires, I said 6 to 9. In our area, it's 6 to 9, maybe 12 months after it's split and covered. The point here is that a lot of people think, well, if you just cut the wood into rounds and leave it, it'll dry out. Wood does really not start to dry until it's split. And then you get all that surface area exposed, and that's when it starts to dry out. So that's an important thing to remember. And also, when you're burning wet wood, you're getting fewer BTUs out of it, because a lot of that heat that comes from the burning is actually being used to chase off or evaporate off the water, and you're getting less heat, but you're also getting the production of a lot of nasty emissions as well, and creosote and things like that. So if you are storing wood outside, you want to have it covered just on the top to keep the rain off it, but you want it open on the sides so that air can get through it. And so seasoning is a real critical thing that anybody working with users is encouraged. I'm going to go past that, but how much is a cord? 4 by 4 by 8 long, face cord, but basically it's half of a cord. 4 by 8 by 2 feet deep. Many people don't know what a cord of wood is, and they buy wood. They really don't know. So if you are buying wood or working with people that are buying wood, it's important to educate them. How much is in a cord of wood? And this is kind of a pet peeve of mine, is that if you call somebody up to deliver some wood, how much does wood weigh? Well, red oak, green, is about 5,000 pounds. Even at 20% moisture, that's 3,500 pounds. Okay. So if you call somebody up and you say they're going to deliver the wood, and they have a half-ton truck, so the question is, can a half-ton truck deliver a cord of wood? I would say no, because a half a ton is maybe 1,000, 1,500 pounds. So, just use some common sense. When you're buying wood, ask what are they delivering it? Is that really going to be a cord of wood? And the other thing is, how much does a truck hold? This is an interesting study I found from Clemson in 1982, where they took Dodge long beds and short beds and an old Datsun pickup truck, and they stacked wood in it randomly and stacked it. And what you see, like say with a large long bed Dodge truck, at the most, even when it's stacked to the top, you're getting a little more than a half a cord of wood. Okay, for a small Datsun pickup, which would be analogous to a Ranger or something you get now, or Frontier, you're talking about maybe a quarter of a cord. So again, just recognize, how much wood does a truck hold, especially if you're buying wood from somebody, and you want to know what you're paying for the wood, whether you're getting a good price. So delivery principles: source wood from reliable places. But if you're interested in this, before the wood is unloaded, check the volume. Is it a full cord or what you thought you were buying? And take a piece of wood, cut it in half or split it, and check the moisture. Is it really seasoned wood? That gives you the opportunity to either refuse to negotiate or act in good faith. A lot of states have requirements for wood, but if it's on its cord, you got a good provider. Tell others. That's what I would tell you. And there is a lot of work going on with kiln drying of wood, and that's becoming more common in some of even the larger firewood markets around here. It's very popular in Europe. That, of course, solves a lot of that problems, and it's going to be dried down to the proper moisture level, but you're probably going to pay a little more for it. And cutting your own tools, cutting your own wood is very popular these days. This does not include the truck or the trailer you own, but it takes a good bit of money to cut your own wood. And these are a couple of tips for chopping your own wood. Never park downhill of the tree you're cutting. When in doubt, park twice as far from the tree as the tree is full. Just because you live within a driving distance of a forest doesn't make you a lumberjack. And perhaps most important is always use your neighbor's truck. So I thought that was just funny. So to finish up, just to say, unlike a lot of other industries, there's not really any real firewood associations out there. There's been efforts to do it. So you don't have a lot of best practices. You don't have a lot of industrial integrity in many cases. That's why I say if you find a good, reliable retailer or provider, make sure you recommend them to others. But finally, I just want to mention for those of you who are interested that on the National Forest, on the National Mall, November 9th to the 14th, the Alliance for Green Heat is going to be sponsoring a wood stove design challenge. And they have all these contestants that have entered stoves, new designs and things like that. And they're going to focus on two things: automation, so smart stoves with sensors and Wi-Fi and things like that, and then producing thermoelectric, electricity from wood stoves as well. And it's going to be over the course of this week. I encourage you to come down if you're in the area and check it out. So with that, best thing to do probably to remove polluting stoves is by encouraging buyout or incentive programs. We need to improve seasoning of wood by all. Buy a meter. We need to improve professionalism of the firewood industry and how it works with consumers, I think. And we need to market pellet stoves as clean and efficient. We have the best practices for outdoor wood boilers, but there's a lot of partnering that's, I think, necessary to educate users, especially new users, to the use of firewood. And hopefully some of this new technology will help reduce some of those problems with wood stoves. So with that, I would, I don't know if there's any questions. On our website here from University of Maryland Extension, I have 9 residential wood energy fact sheets that I developed in partnership with the Alliance for Green Heat, as well as some YouTube videos and webinars. And I would encourage you to go there and check out those resources. Finally, this is the contact information for the Alliance for Green Heat. They actually have a pretty good newsletter they put out on things related to heating with wood. And with that, I don't know if there's any questions. I'll look in the chat to see if I see anything here. I see some folks. Okay. And I'm just kind of reading through, but odds are the incentive program would also direct people to the most efficient units. Well, yeah, actually, that's true. So most of the incentive programs, like I know the one in Maryland, there's actually a list of, EPA has a list on their website of stoves and their efficiencies. So you can look them up. They're being published, so they're there, and ones that meet the new 2020 limits. So that is available on the EPA. And I think I actually had an address, but I think if you just Google EPA wood stoves, you come up to it somewhere. How can we access the list of stove change-out programs by state? I believe the Alliance for Green Heat, www.forgreenheat.org, I think they have a listing on their website of all the various change-out programs, available in different states. Okay, I have one here. What is the install cost of a standard home pellet stove? A lot less than a wood stove, typically, because this depends on the operator, on the retailer. If you're going to have something installed, obviously I would go to a wood stove retailer to have it done. But again, you're talking about putting a 4-inch pipe through a wall. You have to make sure that there's no flammable materials. The best way you can really do this is most counties have plans for what it takes, the standards that are required to be able to install a wood stove. But the cost for wood, I wouldn't say it's extremely high. I'm hesitant to give an amount. Understand up to $3K for purchase price. That's correct. Like I said, you can find some lower price units in some of the big box stores for wood and pellet stoves, but when I look around, when you go to a wood stove retail and you look at Harman and Hearthstone and Yodel and Quadrifire and all that, you're probably more up around $2,500 to $3,000, and you can go higher than that. Inserts can be even higher than that. Okay, and I'm not sure I see. Let me see if I see any other questions that I mentioned. Missed or something here. The cord is about 2.7 tons of wood. Okay. There are laws in Canada that prevent suppliers from selling firewood as cords if it is not a full cord. In fact, most states have laws relating to firewood. In Maryland, they're supposed to state what percentage of a cord the wood is. They're supposed to provide a receipt. But the question is, those things are really not enforced to any great degree. With the issues around transporting firewood and invasive pests, are firewood suppliers doing more kiln drying? Yes and no. I think it depends on the supplier. Certainly for the smaller quantities, that's the case. For the bundles, what I call the bear skin and white wine crowd, certainly most all that material is most of that material is kiln dried. But I do see some people that are selling cords of wood that is kiln dried. It's a big investment. Okay, P25 non-attainment areas in California are phasing out wood stoves, wood burning devices, including pellet stoves. We experience no burn days, incentives for replacing wood appliances with natural gas or propane units, and prohibitions of wood burning appliances in new construction. Well, and I think California has to deal with some different issues than other parts of the country. But certainly in many urban areas, especially where you have inversions and valleys and things like that, there are some more restrictions that are occurring in some communities on wood stoves. Okay. And I think I saw one, those emissions are 2.5. And let's take one more look. And this is a person that says for domestic wood burning to be sustainable, stoves must optimize emission controls, that is hybrid technology combining a catalyst and a reburner, and wood must be sourced locally from sustainably harvested woodlots. Without these criteria, advancing domestic wood burning would be counterproductive. Please speak to those criteria as critical elements of national policy. Well, the problem is in terms of sustainably produced wood, that's a difficult criteria, with the way wood is harvested. And again, a lot of wood comes from urban wood waste. Is that sustainable? I guess it is. But with the sustainable certifications for woodlots in the United States are typically from tree farm. But it's just a very difficult thing to enforce. I think it sounds good, but I think that very, very difficult to enforce. And of course, I work with forest landowners, and we encourage them to get forest stewardship plans, and and folks that are doing that and following prescriptions of a professional forester, I would say, are being sustainably managed. But in terms of having the certification, it's very difficult to enforce in the state. There is a Sustainable Forestry Initiative, which is used by the forest industry, is another possibility. But the idea of stoves must optimize emission controls, hybrid technology, combining a catalyst and a reburner, that would be a hybrid stove for sure. Again, the problem with catalytic converters is catalysts is that in many cases the experience is that they're expensive to replace, and many people end up just removing them or not replacing them, and sometimes the emissions from those stoves are higher. But everybody has their own opinion about some of these things. I think that, Bob, might be pretty much all the questions that I've seen.
I think you have it covered, Jonathan. So thank you. We appreciate you taking the time to present today and everything. It was a very informative subject. And if anybody does have a comment or question left yet that hasn't been answered, feel free to type it in the chat window.
Or they can feel free to send me.
Thank you very much, Jonathan.
Feel free to send me an email or contact me. I'm always willing to talk with folks or answer questions.